Firstly, we're going to look at how to differentiate a vector. This particular vector that I've written down has 3 unit vectors: direction of I, direction of j, and direction of k. I've noted there for you they behave like constants in ordinary differentiation. So I've written down position vector r is equal to 3i plus 2tj plus 6t squared k. So what I'm going to do is differentiate that. So the way I'm going to write that is r with a little dot. That means derivative of vector r. So the derivative of 3 is 0. So what's happened is the I component has gone. Just like if I had plus 3 in a polynomial I was differentiating, and I differentiated 3, that's 0, so it's gone. The derivative of 2t with respect to t is 2, so I get 2j plus the derivative of 6t squared with respect to t is 12t, and that is in the k direction. The next thing I'm going to do is differentiate it again. If I differentiate it again, I write 2 dots at the top, meaning that it's been differentiated twice. So I am differentiating the previous line. The derivative of 2i, or derivative of 2 is 0, so it's going to be 0j, we write nothing there, plus derivative of 12t, which is 12k. And that's how we differentiate vectors. Anti-differentiation is similar. We anti-differentiate each component of the vector, and then we add a constant at the end. Now remember, the constant is a vector. So here we go. We have r dot vector as a function of t equals 2t in the unit vector I direction plus t squared in the unit vector j direction plus t minus 1 in the unit direction k. So what I want to do is anti-differentiate this. So when I anti-differentiate r dot, I'm going to go back to r. So I'm going to get vector r as a function of t equals, okay, the antiderivative of, and I'm going to write this out full, 2t I plus t squared j plus t minus 1 k with respect to t. So the antiderivative of 2t is t squared I. The antiderivative of t squared is 1/3 t cubed j. The antiderivative of t minus 1 is 1/2 t squared minus t, k direction, plus our constant. Now our constant is a vector, so I've written it with a tilde underneath the c. That means that could have an I component, j component, and k component as part of that. What we have been given is a value. It says r dot 0 equals I plus j plus k. That is a mistake. There's no dot on it, so you can can see what I'm going to do, I'm just going to erase the dot and write my r back in. So what does that mean? It means t is equal to 0. So what I'm going to do is substitute my t equals 0 into my new equation for r as a function of t. Looking to the left hand side, I have done that. I've just underlined that. All the terms disappear except for vector c on the left hand side of the equation, leaving me with the right hand side of the equation. I have now found my constant. So what I've done is I've written down my position vector t is equal to t squared in the I direction plus 1/3 t cubed in the j direction plus 1/2 t squared minus t in the k direction plus my constant. Now my constant was unit vector I plus unit vector j plus unit vector k. Though we haven't written it, there is a 1 in front of each of those. Then what I've done is gathered my components together. My I component parts give me t squared plus 1 in the I direction, plus my j component parts 1/3 t cubed plus 1 in the j direction, plus my k component parts, which are the parts I have left, which gives me 1/2 t squared minus t plus 1 in the k direction.